Alright, welcome back to Scottish Dive, doing some Algebra 2. Today we'll be working with logarithms. So before we've been working with exponential functions, and when we had, when we were working with them algebraically, there's no way to, solve for x. And today that's what we're going to learn about. So let's look at y equals 2 to the x again. We know it's an exponential type function. And we're wondering, can we do an inverse? Because if we could have an inverse, then we can work with this algebraically. So the domain, we know this to be all real numbers for the x. Range, y is greater than 0. And the inverse, remember all we do is switch x and y and solve for the other variable. Which we don't know how. But we can graph it. So our inverse is x equals 2 to the y. So all we're doing is swapping our x and y values. So here's x and f of x, the original function. So if I put in 0, 1, 1, 2, 2, and 4. If I put in my inverse function, just flip the values. And with inverse functions, they get reflected over the line y equals x, so that's why that's dashed. And then we're just going to plot these. 0, 1, 1, 2, and 2, 4. And what's going to happen is you're going to get something that looks like that. And then if we reflect it over this, we'll get 1, 0, 2, 1, and 4, 2. Oops, went the wrong way. 2, 1, and then 4, 2. So mirror image. Domain, x is greater than 0, and then this time y is all real numbers. Because all we did was, oops, what's going on? Nothing to save. There we go. Alright. So y, if you don't know this means belong to. It's more of a, here, let me see if I can, there we go. It's an odd E, but that means belongs to all real numbers. Okay. Logarithm of y with base b. So, this new thing is called log with base b, and then of y equals x. If and only if b to the x equals y, and b cannot equal 1. Y must be positive, and b must be positive. Common logarithm. A logarithm with base 10. Which means if I have log of base 10 of x, that is equal to just log of x. So that's why we call it common logarithm. If the base is 10, we just write log. No need to write log base 10. So we just say log of x. Natural log. This is a logarithm with base e. So instead of saying log base e of x, we say ln of x. So those are those buttons that you sometimes see on your calculator. Ln of x, and then probably right above it you see e to the x, and then there's log of x. So now that we have the definitions out of the way, let's start using some numbers and make this more sense. Make more sense out of this. So rewriting. So in general, if we have log base b of y equals x, if and only if b of b to the x equals y. Okay. So we write down our base. So log is 2. So I write 2. And 1 second. Sorry. Okay. So if I punch these into my calculator, I got equals 5 here, equals 0, equals 1, equals negative 2. Okay. So I'm going to follow this formula here. So 2 to the x. Okay. I guess let me rewrite this. So this is equal to 5. This is equal to 0. Equal to 1. Equal to negative 2. So this is the base to the x power. Okay. X is this. Okay. So this is y. And then we have a log of base b. Okay. So 2 to the 5 equals 32. 2 to the 0 equals 1. Oh, sorry, this was 10. Okay, so this is base 10 to the 0th power equals 1. 9 to the 1st equals 9. And then 1/5 to the negative 2nd equals 25. Okay. So that's from switching from log to exponential. And now we're going to switch from exponential to log. Okay. 2 to the 3rd power equals 8. Okay. So this is log base 2 to the y. So y is 8 equals 3. Our x value. Okay. Log base 5 of 1 equals 0. Log base 7. Okay. So remember, this is b to the x equals y. Okay. Log base 7 of 7 is 1. And then this is log base 1/3 of 3 equals negative 1. Alright. Hopefully that's not too difficult. Let's move on to the next page. Okay. Swap. So log of 1. So there's these special logarithms. So the log of any base of 1 is equal to 0. Because b to the 0 is always 1. Okay, log of b with base b. So if we have log base b of b, that's going to equal 1, because b to the first is 1, or itself. B to the first is b. Common log, so we already know about that, which is log base 10 of x. We just call it log, equals log of x. Makes it a little bit easier, right? And then we have the natural log, log base e of x. So we break that a little bit faster, ln of x. Okay. So when you're evaluating logarithms here, you just want to ask yourself, b is raised to what power gives you y? So in this case, 3 to what power gives you 81? Which happens to be 3. Or, not 3. 3 is 27. 4 is 81. And then here, you want to ask yourself, so we have 1/4. To what power equals 256? Okay. So for this one, we know it's going to be a negative number, because that's how we get rid of fractions with exponents. And 4 to the 4th is 256, so this will be 1/4 to negative 4th. So x equals negative 4. Log base 10, so 10 to what power gives me 0.001. Well, we know that this is going to be negative. We're moving the decimal place over 1, 2, 3, so this is 10 to the negative, or 4. I made it over 4, so 10 to the negative 4. So this one's going to be harder. 8 to what power gives you 2? So how does 8 get from to 2? We should hopefully remember that if we take the cube root, which is 8 to the 1/3 power, equals 2. And then lastly, 5 to what power gives you 125? 1 over 25. That would be 5 to the negative 2. Okay. Next, inverses. F and G are inverses, then F composed of G is equal to X, and G of F of X equals X. And so we're going to have f of x be b to the x, and we're going to have g of x be log base b of x. Okay. If we do f of g of x, we'll get b to the log of b to the x. That just equals x. So they're canceling each other out. And we have log base b of b to the x that equals x. So we finally figured out our inverse. We can actually use these to solve equations, but we're going to do that later. So find the inverse. Y equals 10 to the x. So remember, when we're trying to find the inverse, we switch x and y, and then solve okay, sorry. So switch x and y. So x equals 10 to the y. And then we're going to switch this into a logarithm. So ask yourself, so this is log base 10 of x equals y. And that was using our switch from before. Okay. So let's do that again. Switch x and y. X equals ln of y minus 5. Okay. So the inverse of natural log is e. Okay, this is e to the x equals you know what? We're gonna start this over right here. Oops. Sorry. Okay. So we want to get y, or trying to solve for y. So switch x and y, and then solve for y. So now we can use the inverse. Okay. So I'm going to take the log of both sides. Okay. And we use this as our base. So I'm taking the log of both sides. So this is the log of x. I'm going to write base 10 in here for now. Equals the log of base 10 of 10 to the y. Okay. So we know that this is log of x equals, and then we know from before, if we have the same base, these cancel out, and I'm left with y. Okay. Part B. So I switch my x and y, and then the inverse of ln is e. So I'm going to do e to the both sides. So I'm e both sides. So e to the x is equal to e to the ln of y minus 5. Those cancel, and I'm left with e to the x equals y minus 5. So I'm going to, and then lastly, I'm still solving for y. Just move 5 over. So I have e to the x plus 5 equals y. Lastly, oh, this one's harder. So I have x equals log base 4 of y minus 2 plus 1. Okay. I am going to I'm going to subtract 1 over. So I get x minus 1 equals log base 4 of y minus 2. Okay. And remember, okay, so this is log base 4. To do the opposite, I'm going to use my base 4 and put everything into the exponent. So I'm putting this into the exponent here, x minus 1 equals 4 to the log base 4 of y minus 2. Okay. So this is 4 to the x minus, let's erase that. 4 to the x minus 1 equals, these will cancel, and you're left with y minus 2. And then lastly, add 2 over 4 to the x plus 1 equals y. Okay. So when you have a variable in your exponent, you take the log of both sides. If you have a natural log or an e, well, you use, well, if you have a natural log, you use e. If you have e, you use natural log of both sides. And then lastly, if you have a log, you use the base and put everything into the exponents. And that's the hardest one, for me at least. Hopefully you can practice a lot of these. And I believe that's it.